let's take a look at how do we classify real numbers as either integers, rationals, or irrationals. So before we start doing that, let's look at what these terms mean quickly. For integers, we're going to look at any number that has no fraction or decimal. And normally, these are the numbers that people are actually comfortable with. These are the ones that people think of as numbers. When I think about rational, I'm looking at a ratio or any sort of fraction, and that fraction has to involve just integers. And last but not least, if I have irrational, for us that's going to fit into one of three categories. Anything involving pi, anything involving a square root that is not a perfect square. You can use a calculator to check that. And the last category, which is probably the least likely to occur, is any sort of non-terminating, in other words, not stopping, or non-repeating decimal. So it has to be non-terminating and non-repeating, and then it's going to be irrational. And those numbers don't come up that much. So if I turn my attention to the numbers that I have over here, we'll start with 6.51. It's not going to be an integer, obviously, because it has a fraction or a decimal. So I look at rational, and even though it's not a fraction, I can make it into a fraction. If you remember back in elementary school, instead of reading it as 6.51, you could read it as 6 and 51 100ths. I could convert that over to an improper fraction if I would like. So that makes that number rational. And if you're rational, you obviously cannot be irrational also. If I look at the second one, the square root of 42, I check that on a calculator, and I notice that this does not give me a perfect square. So I get approximately 6.48, and then it keeps going on and on forever. So it's not an integer, it's not a rational, so it has to be an irrational, because it's a square root that's not a perfect square. -4 is going to be an integer because it has no fraction or decimal. But I also have to stop and think, is it possible for it to belong to more than just one category? Can I make this into a fraction? And I can by putting him over 1, so he's also going to be a rational number. And you're going to quickly see that every integer is also a rational number automatically. If I look at 1/6, that's by definition a rational number, a fraction involving two different integers. The square root of 49, if I try that in the calculator, or I know it off the top of my head, that equals 7, and 7 is an integer. So it's really an integer that's just dressed up and disguised to look like something that might be irrational, but it's not. And remember that every integer is also rational, because I could change that into 7 divided by 1. When I get to 2 pi, that's going to be irrational because it involves pi, and the pi's don't cancel out. And last but not least, 4.59 repeating. I know it's not going to be an integer because of the fraction or decimal there. And then I think, is there any way I could make that into some sort of rational number? And if you remember the trick, I can make that 59 over 99, so 4 and 59 99ths. Or if you don't remember that, you can remember that every repeating decimal is rational, because for a decimal to be irrational, it would have to be non-repeating, like we saw over there. So that's a quick crash course in how do I classify real numbers as integers, rationals, or irrationals.